So are you able to hear my
आवाज
voice
नहीं आ
and
रहा है सर।
now voice is clear?
नहीं।
क्या हो रहा है?
ऐसे सर खांसी खांसी के जैसे आवाज आ रहा है सर। ड्रम 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 आवाज आ रहा है।
अभी आवाज सुनाई दे रहा है?
Yes, sir.
And PPT is visible to you all?
हाँ अभी हुई सर।
Okay, so let's start. Okay, today we'll start with our unit 6, which is advanced machining processes. So here we will see different advanced machining processes, and this is your syllabus for advanced machining processes. That is unit 6. First, introduction and machining processes, its different classifications. Okay, then we will see different principle, different working criteria or working procedure, different process parameters, and how we estimate the material removal rate, that means MRR, and different advantage of different types of advanced machining processes. Okay, then we will see limitations and applications of it's like EDM process, LPM process, AJM process, USM, ECM, different advanced machining process. So shall start. First, introduction. So before starting with advanced machining process, let's few recap of manufacturing processes. What is manufacturing processes? So your manufacturing processes can be broadly divided into two groups. First one is primary manufacturing processes, which means that primary manufacturing processes which provide basic shape and size. And secondary manufacturing process is it is the final shape. When you provide the final shape and size, where following tight control on dimension, tight tolerance on surface characteristics, then it comes under secondary manufacturing processes. Then again, in the if you talk about the how we do the material removal process, so in respect of material removal process, once again it can be divided into two groups. One is conventional machining processes, second one is non-traditional manufacturing processes or non-conventional manufacturing processes. So till now you all have seen conventional machining processes, and we also gone through different types of conventional machining processes like turning process, drilling process, milling, shaping, etc. All these are conventional machining processes. So now we will start with a new category of machining processes, which is non-conventional manufacturing processes, or that is also known as non-traditional manufacturing processes. Means these are not traditional. Here we use, why called as a non-traditional? Because here we use non-traditional energy source. Okay, like in conventional machining processes, they are mostly material removed in the form of chips. You all know that in conventional machining processes, material is removed in the form of chips by applying different types of forces on the workpiece. Okay, by with the help of a wedge shape or a sharp edge wedge shape cutting tool that is harder than the work material under different machining conditions. So these are just about conventional machining process. In conventional machining process, mostly material removal is take place in the form of chips. How? By applying forces on the work material or workpiece with a wedge shaped cutting tool or with a sharp cutting tool. That is means your cutting tool should always be harder than work material under different conditions. That is conventional machining processes you all know. So now what is non-conventional processes or also advanced machining processes, or also you can know tell it as a non-traditional machining, NTM. Remember that. Advanced machining processes or non-traditional machining processes, or another name is non-conventional machining processes. So in traditional machining processes, mostly based on removal of materials using tools that are harder than the materials themselves. Means machining takes place in the form of chips, or material removal takes place in the form of chips, as well as your cutting tool. It must be harder than the workpiece material. Okay, but here it is different. So we will see what is the background of non-traditional machining process. So nowadays, with the advancement of technology, the advance of materials technology, new and different novel materials are coming up. Okay, with greatly improved different chemical, mechanical, and thermal properties. Okay, so those materials, those new and novel materials which have been improved chemical, mechanical, or thermal properties, it is sometimes very much impossible to machine using different conventional machining processes or using different traditional machining processes. Okay, because traditional machining methods are sometimes ineffective in machining hard materials like different ceramics, different composites. Okay, or sometimes traditional machining processes are not effective when we need to follow a tight tolerance, a very close tolerance we need to follow, or sometimes different micro machining process, or to make different micro machine components. In cases, traditional machining processes are sometimes ineffective. Okay, again, another disadvantage or limitations of conventional machining process is that sometimes during conventional machining process surface damage occurs. With the same time, different stresses, different internal stresses are created in conventional machining processes. Different industries, like different electronic industries, different aerospace industries, where the product should not be any internal stresses. In those products, there should not be any internal stresses. Okay, as well as there should not be any surface damage. So to avoid surface damages, to avoid different stresses which can be occurred using conventional machining processes, we can use advanced machining processes or non-conventional machining processes or non-traditional machining processes. So these are the reason that we need to jump from conventional machining processes to non-traditional machining processes or non-conventional machining processes. Okay. Now we will see what are the major characteristics of non-conventional machining. In the conventional machining processes, as you know that the material is removed in the form of macroscopic chip, by the form of macroscopic chips by shear deformation. Okay, in traditional machining processes, in conventional machining processes. Also, material removal takes place due to the application of cutting forces. Okay, mainly cutting forces means your energy sources that most of the time is mechanical. Okay, then another is, you all know, cutting tool is must be harder than the workpiece material at room temperature. Okay, so these are the things, these are the major characteristics of conventional machining process. So, but what is non-traditional machining processes? Like, or non-conventional machining, manufacturing or machining processes. So, non-conventional manufacturing processes is defined as a group of processes that remove excess material by various techniques involving mechanical, thermal, electrical, or chemical energy, or combination of these energies, but do not use any sharp cutting tools. Okay, so this is your conventional, non-conventional manufacturing processes. Means in non-conventional machining processes, we use a non-conventional energy sources that not conventional, that non-conventional, maybe mechanical, maybe thermal, maybe in the form of electrical or chemical energy source, or maybe in combination of any of these. Also, in non-conventional machining processes, we don't use sharp cutting edge or harder sharp cutting edge, which we must use in conventional machining processes. Okay. So now we'll see what are the major characteristics of non-conventional machining processes. Like in non-conventional machining processes, material removal may occur with chip formation or even no chip formation may take place. Okay. So this is the difference from conventional machining processes. In non-conventional machining processes, material is removed, but not sometimes it may be in the form of chip, or sometimes there is no chip is formed. Like in abrasive jet machining. In abrasive jet machining, the chips are formed of microscopic scale. These chips are microscopic scale, very small. Very you can't sometimes you can't see single chip with the naked eye. Okay. So in like AJM, the chips are form of microscopic size, and in case of another non-traditional process, which is electrochemical machining. In electrochemical machining, material removal occurs due to electrochemical dissolution at atomic level. So as you can see here, the material removal occurs due to electrochemical dissolution at atomic level. These are the difference from conventional machining process. What now? What are the major characteristics? As I already told, in non-traditional machining process, or in short, we will call it as a NTM. Okay, remember that. In short, we will call non-traditional machining process or non-conventional machining process as NTM. So in NTM, there may not be a physical tool present. For example, in laser jet machining, machining is carried out by laser beam. Okay, but another machining process like electrochemical machining, there is a physical tool that is very much required for machining. So in NTM, different NTM process, there physical tool may be available or may not be available. Okay. Another major characteristics in NTM is the tool need not be harder than the workpiece material, like which is very much required in conventional machining process, which is not required in non-traditional machining process. In NTM, the tool need not be harder than the workpiece material. Like for an example, EDM. In EDM, copper is used as the tool material to machine hardened steel. In EDM, copper is used as the tool material to machine hardened steel. So as you know that copper is very much light material compared to steel. Steel is very much hard, very much harder material compared to copper. But still, in EDM, you can use copper as a cutting tool. So which is not same like conventional machining process. Okay. Another characteristic is like in conventional machining processes, you have seen that we generally use mechanical energy sources. Okay, but in NTM process, it is not necessary to use mechanical energy for material removal. Here we use different energy domains like USM, AJM, WJM. There we use mechanical energy, but ECM, here we use electrochemical dissolution. EDM, electro discharge machining. Here also we use electrical as well as mechanical, both combination of these two. And ECM, like electrochemical chemical energy source we use. So you can see what are the difference from conventional machining processes. Okay. So do you understood now? Or anyone having any question, you can ask me.
Sir, last time your voice was break, sir. So can you repeat one more time, sir?
Which one you need to?
Sir,
Last point. This
last.
point.
No, sir. Before that, sir.
Yeah. Like Okay, what are the major characteristics in
No, sir, before that, sir.
this one.
Yes, sir.
So this is also already we have discussed. Same thing we will discuss. Okay, no. Okay, quickly I will do that. Okay. So first, in NTM process, physical tool is present. Sorry, physical tool may be present or may not be present. But where physical tool is always there in conventional machining process. But in non-NTM, there may be physical tool is available or may not be available. Okay, like laser beam machining or laser jet machining. There we use by using laser beam. No physical tool is available. But in electrochemical machining, there physical tool is available. Okay. Another major characteristics of NTM is that here in NTM the tool need to be hardened. Okay, this is correct. In NTM the tool need not be hardened. Remember that. In conventional machining process, the tool must be harder than the workpiece. But in NTM, the tool need not be harder than the workpiece material. For an example, like in EDM or OR EDM, we use copper as your cutting tool. So copper is very much soft, very much light material. But using that copper cutting tool, you can cut very hard material, like from very hard composite material, very hardened steel, very hard material also you can cut. So in NTM, it is not necessary that your cutting tool must be harder than the workpiece. It is not necessary. Okay. Another important characteristics in NTM is in NTM we use different types of energy sources. It may be mechanical energy source, it may be uh, chemical, thermal, electrical, many energy sources can use, many domains, or many non-conventional energy sources we use. Okay, which is not similar to your conventional machining. Like in USM, AJM, WJM, there we use mechanical energy sources. Like in like LBM or laser jet machine, we use laser beam, laser energy source. In WJM, the water energy source we use, abrasive jet machining. There we use abrasive energy source. This is kind of mechanical energy source. Like ECM, we use chemical energy source for machining. In this way. So these are the difference from your conventional machining process to non-conventional machining process. Now we broadly classify different types of non-traditional machining processes. Okay. So non-traditional machining processes can be classified according to the source of energy. What type of energy source we are using to do the material removal, to do the machining. Okay. In that way, we can classify non-traditional machining processes or NTM, like different energy sources like mechanical, thermal, chemical, electrochemical, etc. These type of energy sources we use. So based on that, we can classify different NTM processes. So first, very common is mechanical. When we use mechanical source of energy, when we use. Okay, like what happened in mechanical energy sources? Erosion of the work material by a high velocity stream of abrasives or fluids, or maybe both. Okay, so in mechanical energy source, when we use that time, work material erosion is done by a high velocity stream of abrasive or high velocity stream of any fluid. Okay, again in thermal energy sources, when we use, what happen in that, the thermal energy is applied to a very small portion of the work surface, causing that portion to be removed by fusion or vaporization of the work material. The thermal energy is generated by conversion of electric energy. So you can see here another type, thermal type. Is there we use thermal energy source which is generated from electrical energy, and that thermal energy is applied to a very small portion of the workpiece. And when what happens when we apply this thermal energy on a small portion, the material get removed by the form of fusion or vaporization of the work material. Okay, so in this way thermal energy source will work. Then electrochemical, like you all of you may know that electroplating. Okay. So in electroplating, what happen in a some by using different electrochemical energy sources, a layer of one material is formed on some workpiece. But in when you do the material removal, that means you need to remove the material. So you can say that is reverse of those electroplating. Means material get removed by the action of electrochemical, or by the source of electrochemical energy, the material get removed from the workpiece. Okay. Next one is chemical. When you use chemical energy source, so what happen? Different material which are mostly susceptible to mechanical attacks by certain acid or other agents. Okay, for those material, what we do in chemical machining, chemicals we use or we selectively choose different types of chemical, and those chemicals are used for removal of material from the workpiece. Okay, like there we use those chemical in some selective portion of workpiece. So material get removed from those work part where we applied the chemical, and other part will remain as it is. Okay. So in chemical energy sources, we generally protect those part which no need to get material removed by using a mask. Okay. So these are the different energy sources through which we can classify non-traditional machining processes. Okay. So this you can see here some example. Here are more other examples also there. So like if you see by mechanical energy source, then there are different NTM processes like USM ultrasonic machining, WZM water jet machining, AWZM abrasive water jet machining. Then also another is AJM abrasive jet machining. Okay. Again, if you use thermal energy source, then there are again different numbers of NTM processes like EDM, electro discharge machining, EBM, electro beam machining, LBM, laser beam machining, etc. All these are comes under thermal energy source, or you can say these type of NTM processes use energy sources. Okay. Like ECM, CHM, all these are used chemical or electrochemical energy sources. Again, is the same thing, classification of NTM process. As we already know that classification of NTM processes is carried out depending on the nature of energy used for material removal, or what type of energy sources is used for material removal. Okay, so these are the different classification. So if in your exam it comes like classify NTM process, in those cases you have to write that classification of NTM process can be done depending on the source of energy which is used for material removal, and then you can describe like for mechanical process, how the machining actually occurs. Then different example like AJM, USM, WJM, AWJM. Then you can write thermal energy or electrothermal process. Okay, like this chemical process, electrochemical process, like this way, and you have to give few examples. Then, so this is done with your classification of NTM process. Now we have seen that what are this, what is NTM processes, how it is different from conventional machining processes, and also what are the energy sources we are used, or how we classify NTM processes. Now let us see what is the need of NTM processes. Okay. This is also we already discussed. Like suppose if you want to machine a very hard or very much brittle material, or some material which is very much difficult to machine using conventional machining processes. So for those cases, we must use non-traditional machining process or non-traditional energy sources, okay, to remove material or machine material. Then uh, when work in a workpiece, you need to support different types of cutting forces, which is your work is depending on your cutting forces or grinding forces. You are not sure that whether the workpiece will be sustained when we use different type of traditional processes, traditional machining process. In these cases, we use non-traditional machining process. Again, suppose your product or your final product, which is very much complex in design, complex in shape, or suppose this is very much final product, or you can secondary machining process, where a close tolerance you need to follow. You need to undergo very close tolerance. Suppose that material, that product will use in aerospace or any rocket, okay, or any thermal boiler, where close tolerance you must follow, otherwise there may be a huge accident. So all those cases, so when we need to maintain a close tolerance, very much close tolerance, at the same time the product is very much complex in shape, complex in design. For all these cases, we use non-traditional machining processes. Again, if you want to make intricate shape blind holes, okay, those cases means their hole diameter is very small but very much depth hole. There, those cases we use traditional machining. We can't use traditional machining process because for that much hole you can't make. Your cutting tool will get break. Surface finish will not be good. For all those cases, we use NTM process. Okay. Then machining of composite materials. Also, in those cases, we don't use traditional machining process. In those cases, we use non-traditional machining processes. Then, after classification, now we will slowly we will see different types of NTM processes. So first, let's continue with mechanical machining. Means those NTM processes where we use mechanical energy sources. Some example of that is ultrasonic machining and water jet machining. Okay, so these are good example of single action mechanical non-traditional machining processes. So here mainly mechanical energy source is used for USM as well as for WJ, water jet machining. Okay. In those cases, the machining medium is solid grains suspended in an abrasive slurry in the former, while a fluid is employed in the WJM process. Like in USM, we use the machining medium is solid grains, which are suspended in an abrasive slurry. Whereas in WJM, we use a fluid. Okay. So in details also we will see. Don't worry in that. So next is the introduction of abrasive to the fluid jet enhances the machining efficiency and is known as abrasive water jet machining. Here we use abrasive for machining, like very small abrasive we applied in the form of jet. Okay, these are known as abrasive water jet, or sometimes water also mixed. So if water and abrasive both are mixed, then it is called as abrasive water jet machine. But when there is no water is machine presence, only abrasive is used for machining, then it is known as abrasive jet machining. Instead of abrasive, we can use ice particle. So in those cases, ice jet machining can say, or you can say. Okay. Now, thermal machining. In thermal machining, what happened? Thermal machining removes material by melting or vaporizing the workpiece material. So remember that in thermal machining, material is removed by melting or vaporizing of the workpiece material. Vaporization or melting of the workpiece material. In that form, we remove material from workpiece. Okay. And in many secondary phenomena occur during machining, such as microcracking, formation of heat affected zone, radiation, etc. So, melting and vaporization is primary thing, but at the same time, different microcracks, different heat affected zone, different radiations, these kind of things appeared during thermal machining process. The source of heat could be plasma as during EDM and PBM, or photons as during LBM, electrons in EBM, ions in IBM, etc. So again in thermal, if you subcategorize it, in EDM process plasma is used, okay, and photons are used in LBM, electrons are used in EBM process, and ions are used in IBM process. So these are the different subcategory of thermal machining. Here also very nicely this categorized thermal machining process. Like in EDM, you can say by discharging of plasma, material is removed, and there is workpiece should be dielectric medium. Okay, then in EBM process we must use electron beam. Electron beam means electrons, and their vacuum is should be there in workpiece, where workpiece should be in vacuum condition. In LBM, laser beam is used, means the photons are mainly uh, applied for workpiece removal or material removal. Okay, then air criteria is that like in EBM it should be vacuum, but in LBM air should be there. Then in PBM plasma beam machining, plasma is used. Okay, and the workpiece should be in a gaseous environment. Then in IBM, ion beam is used, or you can say ions are used, and again workpiece should be in vacuum condition. So these are in general little classification of thermal machining. Like chemical and electrochemical machining. Now, chemical milling and photochemical machining or photochemical blanking all use a chemical dissolution action to remove the machining elements through ions in an adjuvant. So, in chemical milling or chemical machining or photochemical machining, there a chemical dissolution is used. Different chemical agents are used, which in the form of chemical dissolution remove the material where it is needed. Okay. Then electrochemical machining use the electrochemical dissolution phase to remove the material, and that is done by ion transfer in an electrolytic cell. Okay. So these are a little bit about chemical and electrochemical machining process. So many processes we have seen, and we also gone through what is the main criteria of thermal machining as well as mechanical machining or chemical electrochemical machining that we have seen. So now let's start with a special manufacturing type process or very much useful NTM process, which is abrasive jet machining. Okay. Now we will see what is abrasive jet machining. In abrasive jet machining, or which is in short, it is known as AJM, abrasive particles are made to impinge on the work material at a very high velocity. Understood? In abrasive jet machining, different abrasive particles are made to impinge on the work material at a high velocity. So, what is the important here in abrasive jet machining? Abrasive materials. So, those abrasive materials are impinged on the work material, and that is done at a very much high velocity. Okay. So, when that high velocity abrasive particle impinge on the work surface, then what happen? It remove the material by micro cutting action as well as brittle fracture. Okay. In the form of micro cutting action or brittle fracture, that high velocity abrasive particles remove material from your work surface. Okay. Remember that. In AJM, generally the abrasive particles of around 50 micron grid size impinge on the work material at velocity of 200 meter per second from a nozzle which inner diameter is 0.5 mm with a stand-off distance of around 2 mm. So if you see in this line, there are many things has been written. Many, what are all those things? These are your different process parameter. When your abrasive jet machining and different type of energy sources are used or abrasive particle are used, but if you remember this line only, this if you understood this, then you can see there are different machining processes or different process parameters are already discussed here. First is in abrasive machining, abrasive particles should be there, and those abrasive particles, what is the size of those abrasive particles? 50 micron grid size. Okay, and at as I already told that abrasive is impinged on work surface at a very high velocity. So how much the velocity? It is 200 meter per second. Where that velocity or that abrasive is come from a nozzle. So in that nozzle, what is the inner diameter of the nozzle? It is 0.5 mm. And what is the stand-off distance? Stand-off distance is 2 mm. Now what is stand-off distance? Stand-off distance is, you can see in this figure, this stand-off distance means the nozzle surface and your workpiece surface, the difference between your nozzle surface and work surface, this distance, or you can say the distance between nozzle and your work surface is known as stand-off distance. So in abrasive jet machining, the stand-off distance should always be 0.5 to 15 micron. Sorry, 15 mm. 0.5 to 15 mm, depending on what type of grid size you are using. Okay. Then here grid size again, or your grid diameter is, sorry, nozzle diameter here. The nozzle diameter is 0.2 to 0.8 mm. So in average you can say 0.5 mm, or you can write 0.2 to 0.8 mm. Both are correct. And particle size is 1 50 micron particle size. And what is the velocity? Velocity will be 150 to 300 meter per second. In an average, you can say 200 meter per second. So these are the different process parameters, as well as in a single slide you can see with nicely we have discussed the different phenomena or even working principle as well as different process parameters. So now we will see how this material is removed due to the action of your abrasive. Okay. Abrasive particles impinges on the work surface at a very much high velocity, and this impact causes a teeny brittle fracture, and the following air or gas carries away the dislodged small workpiece particle. The process is more suitable when the work material is brittle and fragile. So remember, when your workpiece is brittle in nature, that time we generally use abrasive jet machining. So what happened in abrasive jet machining? When your abrasive grain impinge on your work surface at a very much high velocity, then an impact is formed or an impact that causes brittle fracture. As you can see, brittle fracture of your workpiece, a small brittle fracture. So when there is a small brittle fracture, then what happened? That brittle fracture or that fractured material, it get dislodged from your workpiece. Okay, it get dislodged from your workpiece. So then when we provide following air or gas, in abrasive generally use air or gas. Okay, so that air or gas that will remove that small portion, small dislodged work particle like this. You can see wire particle carried away by flowing air or flowing gas. So that will take away your dislodged material, small material, and a cavity is formed. So when this action is continuously will be done, then we will get a very much high material removal. Okay. So this is the action. This is the step to remove workpiece material. First, it get uh, during the action of abrasive particles at a very high velocity, brittle fracture occur, and that dislodged particle that carried away by flowing air or flowing gas, and cavity is formed. In this way, we machine our abrasive jet machining. Okay. So now we will see what is the work, working structure or work setup of your abrasive jet machining. Okay, so that will see that later on. We will see. Okay. So anyone any doubt in that?
Why do you take it in Webex, sir, instead of Google Meet?
Okay. So actually, we need to record our classes.
No, sir, actually, there, but if there is some network problem, instead of in low network problem, we can do Google Meet also, sir.
See, I generally took classes in Google Meet, but we need to record our class, our online class. So that's why sometimes we need to take some classes in Webex also. Okay, but
Yes,
I
sir,
will.
but
Yes, I
actually,
understand.
sir, I was
I
saying that, sir.
understand. I understand that, Kunj, that there is some network issue. So mostly I will take classes in Google Meet. Okay.
Okay, sir.
But still, we need to record our classes, which is not possible in Google Meet, because
Yes,
Google,
sir.
Google Meet which you use, that is free version. So in free version there is no provision to take to record our classes. But our Raisoni college has been taken the license of WebEx. So in WebEx we can record our classes. So that's why some of the classes we will do in WebEx and maximum of the classes we will do in Google Meet.
सर आजकल ये
हाँ।
मतलब ऐसे कुछ समझ में नहीं आता सर, सब अटक अटक के आवाज आता है वेबएक्स पे।
Yes, sir.